Let's continue finding critical numbers using this particular example of a function. And as is a good idea to check certain things at the beginning of our work, this particular function, whatever it may look like, is undefined when x is 0. That means x equals 0 will never be a critical number, because the founding principle of the critical number is that it has to be on the function itself. So I'm just going to make a little notation here. Maybe we should use a different color. Undefined when x equals 0. And let me just make it a little bit bolder here. This is not a critical number. I like to tell my students that it's important when we move forward in the chapter. It's an important place, but the definition of a critical number is, first and foremost, it must be on the function. Defined, they would say. So let's take a derivative. The derivative of x is 1, and I could just remind us off to the side here that 1 over x squared is equivalent to x to the negative second power. Then I can apply our power rule to this problem. So I get plus the exponent to negative 2 multiplied by 125 divided by 2 times x to the now negative third power. We see a nice little reduction here, almost like it was planned. Y prime equals 1 minus 125 divided by x cubed. Now this is also undefined at 0. We were expecting that because the function was undefined in the first place there. We've already established that x equals 0 can't be a critical number. So we'll move on to our next part of the process, and that is finding out when does this, that derivative, in other words, when does it equal 0? That's what we're going to solve. 1 is equal to, if we add this term to the other side, 125 over x cubed. Do we like fractions? No, but we need to be able to work with them. I'm going to multiply both sides by x cubed. And if you didn't notice it before, now it should be very obvious. Somebody made this problem that kind of liked us a little bit, because 125 definitely has a nice cube root, and that is 5, and it's the positive one only. So our critical number for this particular function is when x is equal to 5. I'm a little off the paper. Let's slide it up here. There we go. There's our original function, and here is our critical number. There you have it. Slightly different algebra than before. We need to practice. So hope this example was somewhat useful. Until next time.